Okay, are we on? We're supposed to be on. Welcome everyone. How is everyone doing? Good evening, good morning, good afternoon, good night, good whatever. How are you guys doing? So, we are back. Okay, first let me have a sound test, that's fine. We have music. Let me test chat. Chat looks good. So, let's go. So, yesterday we started the CAM series of the upcoming project, the Milo CNC machine. So we covered most of the basics. We're gonna get into more stuff as we go along with different parts, but we covered pretty much all the basics. I just kind of went into a early process of the setup sheet, which I'm gonna be doing today, like definitely, and showing more in detail the problems that I spoke about. It was late, I was tired, and yeah, it was a long day yesterday. Today as well, but it is what it is. So today we're gonna do a few more parts. Hopefully we're gonna move faster, since yesterday was a lot of explanation of what we were about to do. Everything was new. I tried to cover pretty much everything I could remember. But yeah, so today we're gonna go again, and hopefully we're gonna do a few parts today. So, what more? I haven't been talking about, or at least very much about, Lab 4450. It's my sponsor. It's a Portuguese online store for 3D printer related stuff material. Probably they will carry my CNC Milo kit if we go up to that, and if it shows some kind of interest. What else? So link is in the description, check them out. It's a very nice guy. It's the only guy that actually agreed in sponsor me with some stuff. Tomorrow I believe I'm gonna receive a care package from him. Many thanks, Pedro. Hey Joseph, how are you, my friend? So yeah, let's get going. So I'm gonna open Fusion up, and let's get back into what we missed yesterday and continue with our parts today. So as I was saying, let me open Fusion. Okay, Fusion is actually open. So as I was saying, yesterday I kind of went in a hurry about the setup sheet, which is kind of important. Nice, thank you very much for that. Okay, so yeah, I'm gonna be selling it myself, but if there is interest, but probably the guy from Lab 4450, if there are some interested parties, it's gonna be a good platform to deliver. But we'll see. I'm gonna sell at the same price because I don't want to take any clients from him, so it doesn't really matter if you buy from me or from him. What are we doing? Okay, we are doing here. I'm a bit slow. I had a very low sleep tonight, or last night, because I went to bed like 3 a.m. and I woke up at 7 a.m. Not woke up, actually I got up. Okay, so yesterday we did the skirt. Skirt, it's here. So we're gonna finish the setup sheet. Okay, so as I said, every time you create a setup sheet, you're gonna create it's gonna take like a screenshot of your workspace. So you, for each setup, you kind of have to align the parts in order to understand the information you need from the picture. And the information here from the picture, it's about the origin point or the 0 point, or so we are kind of well set up this way for the first setup. So we're gonna just create a setup sheet. Let's create a folder for it. So I have drawings in setup. So this is my shared folder on my network that I have all my stuff. So not BR, sorry. We're gonna create a new folder called Milo CNC. And I'm gonna just select the folder, because like I said, you don't get to choose the name. It just creates an HTML file with the name of the file. It's gonna be the name that of your part on Fusion. And if we go here, see, now I'm gonna actually rename it. I'm gonna put skirt, and I'm gonna call it back, because it's the back side of the skirt. Now I'm gonna call it one back. So one, it's gonna tell me that it's the first setup, and back it's the orientation. So we're gonna go for the second setup now. So again, I'm gonna orient the model in order for me to understand where the origin is. So again, setup sheet, same folder, and as you see, it creates exactly the same name, which it's very kind of stupid. So I'm gonna call it 2, and I'm gonna call it 2 front. So I know it's the setup number 2, and it's the front side. And see, it creates kind of a screenshot, so you can locate immediately your origin point. So now the bottom, same story, oriented. You can actually, if you really want detail, you can do something like that, but I like to see the whole part. I just need to check where the origin sign is. Setup sheet, same story. Okay, it's saying that contains error, doesn't really matter. It's just because of our disabling and enabling the chamfers. Okay, and let's rename it. So I'm gonna call it 3 and bottom. yeah, that's it for now. The 1, 2, 3 also kind of helps with the ordering. So yeah, let's go for next. Setup sheets are done. And let's move to other part. So we started at the skirts because it seemed like the easiest one. They are all pretty much easy, but some are easier than others. We can go for the spindle mount now. So this is the design that I ended up with. It's pretty simple. And we have some stuff going on here. So I'm not sure. I'm going to leave these. No, it's pretty much defined that it's going to be like this, so we should be fine. So let's go do a simple cam for this guy. So again, same story. We need to go to the manufacturer environment. We need to create a new setup. Okay, let's check where do I have the stock for these guys. So this is XMM, so that's the X motor. So we have one spindle here, two spindles. So 2 blocks for the spindles brackets. So I like to use the factory cut, usually straighter than mine. So we have like close to 120 and close to 112. So if we go to the stock, again I explained this pretty much everything yesterday, so I usually use relative stock. So here we have 112 and 119, so we are pretty close on my stock. I'm gonna add like an extra half a millimeter, so I get 120. Again, I'm gonna use the centered origin because it's gonna split the material everywhere. So if we have some extra material or some missing material, it doesn't really matter because the cut it's going to be even. Okay, stock top, as I said yesterday, I usually do 0, and it's a 25 millimeter stock. So we have a 22 millimeter, so we're gonna add 3 to the bottom. So we're gonna get 3 in here. So this will be good enough to hold the parts. Let's get back here. In terms of orientation, I'm gonna cut it this way. So we need to reorient the origin. The Z is fine, so but let's select it anyway, and the X we're gonna use this line and we're gonna press flip, so we are pretty much in the right orientation like that, and everything else it's fine. You can select the machine if you want. Let's select, and that's fine. Okay, so in here, so I'm gonna use my main mill. It's gonna be, oh yes, I use good vices, and my vices are straight, like smooth jaws. So it's not even like some kind of gripping system, and it holds it perfectly with no problem. I never, well, I had once, but once I had a part flying, but it was because I forgot to actually tighten the vise. It wasn't because of I tightened and it slipped. No, it was actually, it was not tight, and actually made a dink on the enclosure. Thankfully it didn't hit the glass. It was on the aluminum sheet, so it made a dink there. But if it would hit the glass, it would most likely break the glass. But yeah, I never had any problems with such a low surface here. But especially if you have so I'm designing some vices for this. Actually, I'm gonna try to machine the first prototype this next week. So, hey Diogo. Nah, vacuum table, it's cool, but it's better for wood. It's better for plastics, for big panels. For this kind of stuff, nah, I prefer vices. Vices are the way to go. Even I even prefer super glue to the, for aluminum, to the vacuum. Okay, so let's go. So I don't, this part is kinda tricky, but because we need to pay attention on these on this bracket part, because it's going to be weak. So we won't machine the full slot here until the very end. But let's go into that. So how much do I have from here to here? So I have, this is kind of a random number. Okay, let me take a look into the design first, because I usually don't have this kind of stuff. So most likely I forgot. Oh no, actually it's fine. It's a different chamfer? Why is it not supposed to? Oh, okay, I wasn't selecting the line. Okay, I see the problem. It's not a problem, it's fine. Okay, so this thing, I'm gonna machine it with a 8mm mill. We're gonna start with an adaptive clearing, of course, and let's select the profile. Note that I selected the so the big profile from the chamfer, not the small one. Pay attention to that. That's another reason I kind of don't like to model the chamfers. Actually, we can deactivate the chamfers. And it's gonna complain because I selected for my x-axis I selected the chamfer line. Back again. Flip it. Okay. Okay, so let's start with 2D milling, adaptive clearing. Let's select. So without chamfers, there's no mistakes, or there's at least it's less probable to select the wrong profile or the wrong line. Let's go with my trusty 8mm mill. So what I like to do, since we have a 3mm lower stock, well, I forgot. Well, we can do that after. We have a 3mm, so I like to go minus 0.4 under. No, actually minus 0.2. And here I'm gonna, the stock to leave, I'm gonna leave some radial but no axial. Let's select smoothing. Load, let's put 2.5 load. Should be fine. We can do, yeah, we can do all at once. Since the flutes are 24mm, the flute of the mill, and we are cutting like 22mm, so it's fine. My machine can take this cut. I forgot to do the first operation that I always do, which is the facing. So let's do that. Usually everything is set already. Everything should be fine. Yep, everything is fine. So you can change, like, drag operations in order to change the order. Now let's do a finish pass. So we're gonna create a derivative operation and 2D contour. Yeah, I'm gonna try to stream the machining, at least of some parts. I can't promise, but I'm gonna try. I can promise I'm gonna try. That's the promise I can make. So yeah, here we're gonna go minus 0.01 and okay, let's see how it will behave in here. I'm not sure how Fusion will behave because we have a 7mm gap and the mill is 8mm, so okay, it behaves exactly as I suspected, so it won't cut the thingy, which is good, but I'm gonna edit because I want to make some stuff different. Okay, so selecting. Okay, what I'm gonna do, I'm gonna edit the operation. I'm gonna go to the geometry tab. I'm gonna clear it. So usually you select full contours, but let's say you want to select just this line, for instance. So you can hold the. There's two ways to do it. You can either select the full line, and now you see every time you select something, you're gonna get chains in here. And then you can edit the close chain, and here is you see close chain or open chain. You can select open chain, and now you can go and keep selecting around whatever you want. like that. See, and now there's not the full scene selected. Or you can press the Alt key and click on the, keep the key pressed and click the profile you want, and you see now it selected an open chain instead of a closed chain. Then we're gonna go here with a smaller mill. Okay, everything else should be fine. And now we have two. So we have the first one that will clear everything around, and the second one that will clean the main lines. Now we need to deal with the slot in here. So let's deal with that. So we're gonna use the what we're gonna use. Yeah, I just need to prepare the main workshop for the streams, and that won't be easy. We'll see. I'm gonna try. So for that we're gonna go with we can go with, let's try adaptive clearing. I'm not very confident about this, but let's see if we can do it this way. At least we can do it. I'm not sure if we can do it this way. So I'm gonna select the 6mm mill, rough. Oh, before I forget, give me a minute. Okay, if we do this, yeah, I don't think it's gonna like it. Yeah, it hasn't done anything because I forgot to select the depth. Here, let me edit and select the finish speeds. Otherwise, it's gonna be a little rough. Okay, let's check if I do. So selected contours, we have 22, we're gonna do like 12mm deep, and we can do it all at once. Let's see. No, okay, as I expected, as I kinda expected. So we can do it this way. So, okay, let's delete the operation. Let's do it the other way. So we could do something like this. If you really want to do adaptive, you can go to the design and you can make what we call machining sketch, where you just draw a sketch in here. That should be fine. Let me just make a 6mm circle in here to make sure. Yeah, we are good. So this is just for 8, and actually for, we can do other things since this is all already machined. So now we can go to the manufacturer and we can go to new operation, adaptive clearing, and we can select this sketch. It won't spring like wood, but it will spring because aluminum it's harder than regular wood, and wood has some organic pressures built in. Aluminum not that much. But yes, it will spring. That's why I don't want to cut it at all. So let's select the 6mm mill rough, and let's use a new thing. So now on the geometry you select the sketch, and you see the blue, it's what it wants to machine, and actually you want to machine inside the sketch. So you press this red arrow and it's gonna invert the selection pretty much. So now we're gonna use something. We're gonna put this, we're gonna radial. Let's lower the cutting radius, and let's also lower the optimal load. Optimal load is the pretty much the amount of material that it will cut on each pass. Like it's going like in waves, and that value, it's pretty much the thickness of the wave. And now here in linking, let's use something. We can use, usually we need to ramp in material, right? But we cut everything inside here and outside here already. So we know where this circle is. There is no material. So we can use that, this thing in here, as a pre-drill position. And we're gonna select that, so that will tell Fusion that we previously made an hole in here and there's no material, so we can go there and plunge the end mill directly instead of going ramping. So it's gonna be faster. What did I forgot? I forgot to select the multiple depths. No, actually not multiple depths. I want a single depth, but I forgot to select here -12. Why is the toolpath empty? Shouldn't be. T5. Maybe it can't cut. Okay, probably it can still cut. Where is the... because I need to put 0.2, not 2. Okay. So see, now we don't have the ramping thing. It's just gonna drop in there because we made sure there's no material there, and it's gonna cut it all the way down. One thing I need to check, actually I may want to do more than 12. Yes, I want to clear all these full holes, so let's put like 15. So my mills are usually 3D, which means 3 times, the flutes are 3 times the diameter. So it's a 6mm 6mm mill. It means it has an 18mm flute. So now, okay, now we cleared the hole, and we leave some material in here, so this thing doesn't close or spring or whatever yet. Now let's do a finish pass. We could create a derived operation, but it doesn't help us because we create this specific sketch for machining. So now we're gonna do the same thing, press Alt, and I'm gonna actually start here on this round corner. And you see I only selected that thingy, so now to continue selecting more I need to press it again, and now I can select the rest. And I actually want to invert because it was the way it was. It's cutting this way on this side, and we want to actually cut on the other way, like that. And we should be fine. Here, if you want to extend, let's say you, I don't know, this is a chamfer, and you want to make sure you want to start a little out and finish a little after. You can go in here and add some extension, and you see it appears here in a trace, the extension portion. On this case we don't need this, so we are fine. Selected contours, let's put minus 11.9 since we did the adaptive clearing at 12. Smoothing on, we should be fine. Oh, I forgot to select the top one, so let's edit and select also the top one. No point on creating two operations when we need to do exactly the same thing on two contours. And oh, actually it's 14.9. Yeah, we start at 12 and then we change to 15, so let's do 14.9. So we have the slot cleared. Now let's do the chamfer. So new operations, 2D milling, let's do 2D chamfer. So now we have access to the whole part. I don't want to chamfer the back side, so I'm gonna press Alt and select the... Also, there's another thing, you don't need to select like this. If you go like that to the end you want, you see it selects the whole path. Sometimes, let me clear the selection. So if you start there and if you go there, oh, actually it goes the whole way. Usually it takes the shorter way, so you need to select like a second part, so it actually understands you want to go the other way. In this way, actually, it selects exactly what we want. So in this case, I'm gonna go a little outside, so I can make sure that the chamfer starts a little out of the part and gonna finish again a little past the part. Let's select the tool. It's a good idea to select the tool we want. So we want the spot drill, chamfer speeds, and let's do just something like 0.8 millimeter. And there we go. We have the chamfer. So we can simulate everything now. See if actually we didn't make any mistakes. So let's start. So let's start with the facing. Let's keep the facing. So it's gonna do the adaptive. Let's keep the adaptive. Now the finishing. Now it's adapting doing the adapting on the slot, the finish, and the chamfer. one thing I'm gonna check on the on here actually. So I'm gonna do the sync, the extension on both these chains, and if you want the same extension on both chains, you can select one and the other using Control or Shift. If you have a big list, you can go from the first to the last. So you select the first, you go to the last. Before you press it, you press Shift and the last, and it will select everything. Or if you want just a few of them different, you can go click one and then press Control and click all the others that you want. I'm gonna go here, align extensions, and let's go 2 millimeters extending. Again, the trace line is there, so we are good. So just to make sure we go, instead of starting on the exact point we want, we have a little extended path to make sure everything gets clear. Okay, so the first hey Beanie, the first setup is done. Now what I want to do, it's actually I want to, while we have some strength in here, and this is why I intended to clear the hole to make sure everything under the hole was machined. Oh, you're gonna go tonight? So now let's machine this screw hole. How much do we have from here to here? Sometimes in computer. Yeah, night shift. Well, good luck, my friend. So we have 40 millimeters, which is quite a bit. I need to use a long bit for machining these. Okay, so let's do another setup. And now we're gonna set up the so for that hole there. So what we're gonna do, we're gonna select Z and X. So Z, it's gonna be this plane. X is gonna be that one. I'm gonna invert it. And when I have machined sides of the parts, I'll stop using the middle and I'll start referencing to the model itself. So I'm gonna use, and I like to use the top right or the front right, front left corner. So it's usually the face that's gonna stand against the fixed jaw on the vise. So like that. Everything else is okay. We have the same stock. For this, we could select the... no, we can leave the stock. Okay, so first we're gonna start boring this guy. So let's new operation to demilling bore. And we're gonna select this guy. So I'm gonna need a long mill for this. I'm not sure if my 6 millimeter long mill, let's see, 6 millimeter. Let's put it on a, and I have here the long. I'm not sure if it's long enough. Okay, so according to if I have my tool set properly on on my CAM software. So we supposedly have under the holder 1, 2, 3, 4, 5, so 50 millimeters above the holder. I'm not sure if I actually have. Sometimes I do this by guess, but it should be. So this is a 25 millimeter. If I remember correctly, yeah, I have pretty much more than 15 millimeters here. I'll double check before I actually machine the part. So we're gonna select that one and the finish steps, speeds and feeds. We're gonna bore the shit out of it, and I'm gonna actually, so this is everything is fine. Base, it's that one, fine. Fine. What I just want to do is just add an extra 0.1 millimeters to clear the hole. Just because it's a long mill, it's gonna flex a little bit. So let's give it a little more. So if you do negative, it means, so this is stock to leave, right? So if you put like 1 millimeter, it means it's gonna leave 1 millimeter behind. So if you do a negative number, it means it's gonna actually eat more, mill more than it needs. So that's why I'm using a negative number. So a negative number, it's gonna make a bigger hole. And yeah, so we have the stock here, but supposedly we're gonna go from the last stock or the last piece, and there's nothing there. So as long as we clear the stock here, we should be fine. And what next? Next, we're gonna make a spot drill with our trusty spot mill, spot chamfer mill. So now you see why I have a long spot drill, because of this type of stuff. So we have selected that. Let's select these all, and so it's supposed to be a 5.2 millimeter hole. So let's do here the bottom height, we're gonna call it chamfer diameter, and we're gonna go down to 5.8 point. And when I'm do spotting, I like to do a dwell to make sure it cuts everything. So it goes down, stays half a second, and goes back up. And we should have a long enough drill for this. Let's take a look. So simulate. Actually, let's do simulate everything. No, sorry. Simulate. Yeah. Okay, so the boring, it's gonna bore. Then the spot, it's gonna spot. I'm not sure. I think I'm gonna drill and tap these manually, just because I'm not sure if I have a long enough drill set on the machine to drill this. No, this one, it's actually 4 setups, because we have 2 holes on the back as well. So I have the spot there, and then I can go just to the drill press and drill the hole there, and I can start with a 4.2 millimeter and actually do the drill down there, and then drill with a 5.2, and then finally tapping the bottom hole. So yeah, it's gonna be like that. So let's leave that to do manually, just because I'm pretty sure I don't have I'm absolutely sure that I don't have a long 4.2 millimeter drill for the bottom, for the thread, so there's no point on losing time. That's three simple operations, just two drills and a thread, so I can do it manually. So let's go to this side to make these two. So new setup again. Let's select X and Z. Z, it's this one. X, it's selected already. That's nice. Same story. Model box, box point, that corner. Boom. Fine. So now we need, this is what? This is M5. So we need two spot drills. So same story. Let's select this guy. Heights. Chamfer diameter. 5.8. Fine. Operation drilling drill. Now, if I remember correctly, we used the 5.2 millimeter on tool 10 on the skirts. This is kind of important just for you, just since I'm always changing the drills that I'm using, so the tool numbers, so I use the T10 and T90 to T99 for drills on my machine. So when I'm on the same project, I try to keep the same drills on the same tool numbers that I used before, so I don't have to be always on the controller changing the tools. So on the skirts, I'm pretty sure we selected the tool 10 for the 5.2 and the tool 90 for the 4.6. We're gonna use the 4.6 in here. So 4.6, it's the drill used to make a form top M5. So let's select both drills or both holes. These are deep, so let's go with deep drilling. Let's do like 3 millimeters packing depth, and on the heights let's drill the tip through, and let's do 1 millimeter or 2 millimeter even, like that. And now tapping. So tapping is a drilling operation. Why? Oh, because I'm clicking the machine and not the setup. So new operation, drilling drill. We're gonna select the tool 11, which is the M5 tap. Select. Tapping, that's fine. Let's go to the geometries and let's tap this, and it should be fine since we do here. You can see, so the tap finish there, the drill it's down to here, so we are fine. We have enough drilling for the thread, and that should be it on this setup in here. So let's go for the final setup. So let's give it some names. So let's put top. The setup 2, it's going to be front. The setup 3, it's going to be bottom. No, back, sorry. And the setup 4, which is here, this side. So let's do the same story. So let's select the Z axis in here. The X axis is actually here. So let's select this line like that. And I'm going to select the model box point and the lower front left box point. So that way I can do the I can measure the fixed jaw of the vise on Y. I can use a parallel on X to measure the machined face of X, and I can also machine the top of the parallel where the part sits on Z. So we are good. Let's rename it to bottom. And we need to do a facing operation. Face with our face mill. So with the face mill, we're gonna remove the top 3 millimeters we have. So we're gonna do, we don't need to select anything. So we're gonna do multiple depths. Maximum step down 1 millimeter, that's fine. Finishing step, yes. I like to do a 0.2 millimeters finishing step. Even step down, no stock to leave, no nothing, everything should be fine. And we should have something like this. So if we simulate everything, yes. So it's gonna start, so we're gonna start like this. Well, actually like this. Then do the front stuff. Then do the back stuff. Topping. And then removing the extra stuff from the, so now we can, when we machine the first side, we can actually grab the tool, the part directly with the vise. Now it's gonna do the finish pass. And so the only thing left to do is the it's finishing the cutout there and do the chamfer. So on this case, I'm not sure I'm not sure what I'm gonna do. Ideally, I would do the chamfer first, then finish the slot, and then finish the chamfer. Would be the best way to do it, but not the more efficient way, because we're gonna need to do two different chamfer operations. So I think I'm gonna risk to cut out the thingy and then do the chamfering. Yeah. No, let's do so we have the tool removal. Let's do the chamfer first. 2D chamfer. On this side, actually I'm gonna do that on the other side as well. I'm gonna put a small chamfer in here just to leave the burrs out of the way. Just let's select chamfer tool, and let's do just a small chamfer. Let's give it some extension. Let's do something like a 0.25mm chamfer in here, just to get rid of any burrs. And actually I'm gonna copy this operation to the top. Yeah, it can be the last one. Control G. Oh no, I need to reselect the sketch line. Oh, fuck. And this way, forgot to do the extension. Boom, like that. So this way we make sure there's no burrs or whatsoever, no sharp corners on that face there, or on that edge. And we can do the big chamfers around, to the milling, to the chamfer. Like that. Like that. No. Control Z. Like that. We can do the 2mm thingy. So we need another chain there. Same story. So here it will be better just to do a line extensions in the end, but okay, I need to delete the last one and do this one. Two millimeter, like that. Oh, I'm selecting the wrong side. Fuck me. Okay, let's go again. fine. I know I didn't select the extensions, but I can do all of them now. Like that. And now, did I select the size of the chamfer? No, I didn't. Oh, I did on that one, but not sure if I did. No, I didn't. 0.8. And now we need to finish this guy in here. So for that we can use the same sketch. New operation, 2D milling, 3D adaptive, 2D adaptive. We're gonna select the same milling. Oh, I'm really sleepy. I won't be able to continue this too much. Like that. Rough. Select. We can select the same sketch. We can do the smoothing. On heights we can go, so on the first time we did 15. It's supposed to be at 22. So we need 7. So let's do 8 minus 8, and but this is from the model top. So we need to do highest selection, model top, that's it. Optimal load, let's put 1, and let's put a 0.2 on mill. Axial 0. I forgot the pre-drill position. There we go. So in theory, the vise will hold this part as well, since we have a little face there that's the same dimension or in the same plane as that one. So it should be fine. Let's do the finish pass. Milling 2D contour. Same mill. Same contour. Why didn't you select it? Okay, no, it did. And let's do, no, we don't need anything in here. Okay. Oh, I forgot so selected contours -7. So we should be fine. And what do our, so we are missing only the chamfer in here, right? So let's do that now. New operation, to the milling, to the chamfer. Select. Same tool. Chamfer. Okay. Let's start from the back. Like that. We have a cross there, but should be fine. Oh no, it's not. So this guy until this guy till this guy. Okay, and this guy to this guy should be fine. Oh, I need to select finish. We're gonna use the same as titanium. Okay, let's simulate just to check where we are. So we should do the facing. Okay, let's move the facing. So this is the aqui é quando tu se desorientar uma cachopa, né? So when we need to do this slot, it's supposed to be cut on the other side because we moved everything on top, and yeah, it should be fine. Let me simulate everything just to be sure before making the chamfer. So let me do this one, it's done, this one it's done, this one it's done, this one. I think I forgot to select the chamfer. Yep, I did. So 0.8, that's fine. My brain is shutting down. Yeah, this should be fine. Let's simulate everything. Let's simulate everything. Not there. There. Okay. So face. Adaptive. Finish. We may need to do some extra. I need to measure the spindle to make sure it's like exactly 80 millimeters, or if it's a little less or a little more. We may need to fine-tune that. Yeah, I'll sleep better tonight. So we have the boring on top. We checked these everything. Spot, we have the spots there. We have the drills. Then we have the taps. Taps, tap, tap, tap. Come on. Okay. So we have the face. We have the chamfer, the small one, the big one. We finished the slot. What am I seeing there? I see something there that I don't like. So it looks like I'm leaving something. Okay, let me check. Let me check. So this is a 22mm piece, right? On the first piece we do 15 on the first side. So there are 7 left. Oh, okay, I see the point. I think I placed 7 in here. Heights. No. Okay, so then it's the finish that is wrong. Okay, I forgot to activate the smoothing. Yeah, okay. Here it's wrong. It's 8. Yeah, I know. 8. Boom. And now we should have everything fine. So let's step. Small chamfer, big chamfer. Okay, here we cut everything, we finish, and we chamfer. Okay, that's fine. So everything is done on the spindle brackets. So let's save the setups. Or what do I want? Setup sheet. Milo CNC. I'm gonna select that same folder. This is so stupid. So spindle mount. Let me put some. It's fine in here. I can use space, but I'm used to. So this one, it's the top. Kind of the same. Oh, forgot the one. Top. Front. Setup sheet. Save. So 2 front, and setup 3. Let me orientate it like that. Three. So this is the back. And the last one, it's like this. Yeah, I'm gonna use it. I know what it is. Setup sheet, same folder, and it's gonna be 4. And this is the bottom, right? F5. Okay. Why is this one Why is not this one the first? I think this is Windows playing on me. Spindle mount. Oh, because okay. Let me remove this one. It's better. It's easier that way. Okay, let me. Well, there's no point. Okay, so the spindle mount is also done. Simple piece. Next, let's try to do one more. So, okay, for these, I'm going to machine them all at once. So let me create a new file where I put all the nuts, the nut holders in here, because I'm going to machine them all together. So the way we're going to do it, we're going to orient everything the same way. Shit. Okay, I'm gonna do like that. Yeah, it's gonna be better like that. And so this is the Z. We are missing this one, right? I think the charger. Yeah, the charger just died. The charger of my, not the charger, the power brick burnt electronics. Okay, I need to figure out how to open this thingy. No, I don't think this thing is made to be open. Well, nothing that a Dremel won't solve. Do I have another one? I don't think I have one in here. Okay, so let's continue. Yeah, it kinda. Okay, I fucked up, but like that. Fine. Yeah, that's fine. Okay, so now we can start aligning stuff. Align. Is it me? Yeah, I need to rotate it a little bit. So let's align this. I'm not sure if these work, but nope, doesn't. So align. So these things have, I believe, 16 millimeters, 17 millimeters. So I can machine with a 6 millimeter mill. Yeah. Oh, actually, this one it's slower. That's fine. As long as we have them in the same. Yeah, that's fine. Actually, this one is wrong. I need to recheck this one in a minute. So we have, well, we can align, and we can align. It's easier this way. So now I can move. I press M for move, and I can move them 8 millimeters to the side. Same thing for that one. 8 millimeters to the side, and now it should be fine. Yeah, since okay, I'm gonna call these machining nuts. Since they are all, I'm not sure if they are, but they will be. Okay, so they're gonna be all 35. I need to check if I have the clearance for this one, to be honest. Okay, let's check that. I have a few things I need to check on this one. So this is the X. So let me open it. And let's open the functional assembly. Okay, I see some references out of date. I don't care. Okay, so let's disappear with the... What do we have here? Why do we have so many stuff out of... Okay. Let me disappear with this sketch. Let's disappear with the... Oops. Nope, not everything. The x-axis. Yeah, the x-axis gone. These can go away as well. These, and this. This guy. Would be ideal if I could change the transparency. It looks like I can, so turn off. Okay, so what I need to check is, let me remove this guy as well, this guy, this guy. From there to there, shit, I only have 1 millimeter. Oh, but wait. Oh, it's not this one. Fuck. It's actually this one. Shit. Of course it is. Can I peek under? Yeah, I can. How much do we have from here? No. From here to here. Oh, we have 3 millimeters, so yeah, that's fine. So we can grow this guy 2 millimeters. Hey, there's something wrong in here. Okay, I'm glad we checked these because we have a problem here. We have a big problem in here. That I haven't noticed because I'm stupid. Okay, we have a big problem here, and I'm actually glad that we found it. I need to open this plate. So this is the saddle plate. So we need to change some stuff in here, like these holes. Edit sketch. We're gonna need to change that. And we need to change this design. I don't know what I was thinking about when I made this, because this thing can't be more than 40. So this thing has to be 39, because we only have 40 millimeters between the frames or the beams or whatever. We can do this 35, so it's the same. It's going to be the same size as the others. Okay, we need to fix. We need to fix the. And we need to fix it from the top. So probably we need to move to the center. How much meat do we have in here? Enough. Okay, we have enough on the middle. So we're gonna make two. We're gonna make two thingies on the middle. Okay, this it's gonna be way smaller, maybe like 5. No, can be more, 7. Yeah, 7 looks good. Okay, now the mounting holes. These guys, we're gonna do actually something different. Let me grab an M5 screw, a button head screw. Where do I have an M5? It's here. Oh, I think these guys are something like, yeah, they are. Okay, we have to do 10 millimeters. So we are doing a slot instead. Let's make these lines tangent, tangent, and we should be fine. We create a point in the middle here, in the middle there. And they're gonna be pretty cozy together. So instead of we doing this and this, we're gonna do this. I don't know. 10? Hey, didn't I align these two guys? Probably not. Okay, let's see how this goes down. Otherwise, we can use smaller screws, which is a good option, to be honest. So in here, we need at least what, 3 millimeters? Yeah, at least 3 millimeters. So minus 3.5. but that's still too big. So we're gonna use actually M4 screws. Let me see if I have an M4 screw here. Yeah. I don't like these, but it's the best solution for this problem. So we can use a 8mm slot now. Instead of 10, we can go 8. And of course, we can go 8 in here as well. Should be better. What's this? What's this? Oh, we don't need this yet. Well, we need, but not yet. Yeah, that should be fine. Let me do a... Okay, let me fix this first. Redefine sketch plane. Whoa. Fuck this. I need to edit feature. This minus 33. 32 probably should be fine. How much meat do we have here? 20. 3mm, and this. That's way too much. We don't need nearly too much. Yeah, we need like 2.5mm for this, so 30 should be fine. Here to here, 175. But this one it's a little bigger, so we should be good. Actually, I'm gonna reduce this size on all of them to 22.2. Yeah, I'm gonna give it just a nudge more. 30.5. And I'm gonna redefine this back for here and edit the sketch. Now we're gonna move this one in here. Wait, why the fuck? We're gonna delete that. Move this one here. And these are going to be 4.2s. Like that. Boom. Beautiful, right? And it's not ideal. Well, actually it sucks. It's fine. It's fine. Yeah, I was thinking about something else, but yeah, it's fine. This thing it's fine. Let me open them all because I need to make changes on all of them. I thought about it and I made this this hole in here in the middle. Or you mean on this hole here? I'm not understanding the question. So the ball screws are 22 millimeters. I made these 22 and a half. No, I can't. I can't. Oh, I can't because of the of these holes. You see, we need to put screws in here on one side and the other, so I can't actually make that. Okay, so I'm reducing the diameter of this hole for a more a closer fit, just to make better alignment. That's the changes I'm doing on all of them. So it has a little gap still, but not as much. Okay, it should work. Now I only need to change the drills here. Shit, yeah. So now we are, how much are we apart? 8 millimeters, right? Okay, let me do first analysis, check. Okay, actually it's exactly that, it's just a little more on the middle. Okay, I can actually make it a little larger. So let's do that. Because the further away the screws are one from each other, the better. So let's make it, let's try the 10 millimeters. 1 millimeter more. Yeah, that's fine. That's perfectly fine. That's perfectly fine. So save. Okay, let me remove the analysis because otherwise it's going to be weird. And now I need to change these to, so it's 48. So I need to add 19 to that. It's 48, it's gonna go to 10, that's 38 less. So it means we have to add 19 in here, supposedly. Because this thing is out of center. And the holes actually are a different, so they are 3.3. Fuck. No. Actually it was right. 3.3, and this guy, it's the same as this one. And everything should line up now. Let's see. There we go. Yeah, fuck, I forgot the ball screw, it's gonna pass in the middle. You're gonna need to tighten those screws. Fuck. So one thing, okay, I'm gonna need to make a different. Yeah, I know what I need to do. I need to do this thing bigger, so I have space to do the holes in here more to the side, and still have enough room for the threads. We have the space, so that's what we need to do. So I can't machine this one together with the others. Well, this one is wrong anyway, because it can't be 17 millimeters. It has to be at least 18 millimeters. Well, even if it is, fuck me, I was dumb in here. How much do we have from here to there? Anyway, from here to here, we have 4 millimeters. 4 millimeters, it's plenty. Yeah, it's plenty. Never mind, I'm gonna make it a little thicker. Yeah, that's what I'm gonna do. I'm gonna make it a little thicker. And I just need to machine it differently. I can't machine it on this block. So this, if this is 15.9, which is what it should be, but if you use the normal screws, the normal M4 screws, yeah, the normal M4 screws are 7 millimeters. Yeah, I don't like the idea. Yes, the ball nuts are the ball nuts use 4 millimeter screws. So what we're gonna do, it's this 4 millimeters. It's 6 screws. It should be fine. And actually, this thing can be 16 millimeters and not 15.9. Actually, I can do that on all of them. So this is the X, Y, and Z. Where is the Z? Okay, this one can be 12. Yep. Okay. Yeah, this will be fine. We can do that. We can absolutely do that. Where is it? So I changed this one. That's fine. This one. Okay, let's change this one. Edit. I'm changing this value because the nuts, when they are aligned, they have a small gap in between. So that's exactly what this number here, this weird number, was about. So we can change that. And here we have 6 screws. It's fine with only 5 on an M4 thread, 5mm thread. It's more than enough. We have 6 screws. That's a lot of threads. Even on one side we have only 4, but that's plenty anyway. So what we're gonna do is we're gonna get back to the original plan of the separated screws. No, the squish will be the same. The only thing I'm doing is, since the nuts itself don't go flush, when they are aligned, they have a 0.1mm gap, at least a 0.1. I was assuming that when they were aligned, they were actually together, but they are not. So that's why I had that weird number there, that 0.1mm. It was so the nut wasn't exactly flush on the part and be at 1mm. So yeah, okay, so you see, so that way we can actually grow that. And the squish, actually I ordered a 0.1 shims, a 0.1mm shims, so we can actually adjust the preload. That's something actually I need to change in here as well. We can actually adjust the preload, so we're gonna make the hole a little deeper, and we can add shims to adjust the preload to the way we like it. They should be here tomorrow, so we can shim if we make it deeper, so with less preload, then we can adjust the preload with more or less shims. So we're gonna aim for a value, but a lower end value of preload, and then we can increase the preload as we find it better. I can actually machine one of these pieces, and actually we can test the different preloads, and we can fine-tune it, and when we achieve a value, okay, then we manufacture the actual pieces with the value that we want. Okay, so let's move these things apart. Let's move them. So we have a 12mm, 16mm. Let's put it like that. So from here to here, yeah, we have 4.3. Yeah, it's fine. It's gonna be fine. And if we set it like this, so 16, right? If we set it like this, so now it's 16, so that means 16 in here as well. So now we should have room on the here. So now we should have room to tighten the screws from the side of the ball screw. Fuck you, man. V V, V. So yeah, so now we have room to access the screws from the top. Well, maybe we could do a little more. Well, no, we have room to. I think we have room to pass. Yeah, I think we should be fine. Yeah, we should be fine, and we can actually still machine the pieces from the same stock. Yeah, maybe I'll give it a little nudge more. A millimeter more for each side, maybe. Doesn't hurt, I think. So it should be this guy. So 18. And it does. Oh, give me a second. Let's see how is the. Yeah, it doesn't affect these ones at all. Only affect these ones. So yeah. Yep, that's why I'm increasing the space a little bit, but I'm pretty sure there is space because we have a big hole. The hole it's much bigger than the ball screw, so we have space to wiggle around the screws. But yeah, with 1 extra millimeter it will be absolutely doable. So I changed that. Let's change this one. It's gonna be tight, but so 18 and 15. Fine. Save. How did we miss that on the cut? Weird. Yeah, now it definitely passes, the screws definitely pass through the sides, and we are good. Okay, we are good now. I just don't like... Yeah, it's fine. It's fine. Okay, I'm not gonna save. Then I'll just update the design. And okay, let's update. Nice. So now we need to... Okay, let me check if everything is aligned. It should be. Yep, it is. Okay, let's move this guy 21 millimeters. And now everything is equal. So this is not advisable to do, but since I'm doing this on my machine and I trust it, it's very precise, and my vices are also very precise. So as long as I machine these parts all together, I'll be able to 35. I'll be able to hold them side by side on the vise. They will hold just fine, and it saves me time, and I machine 3 pieces at once. And since they are quite complex parts, with threads and whatsoever, it saves time. It saves a lot of time. Okay, so what's sketchy? So here, yeah, we should be fine, because yeah, it should be fine. This guy can actually be longer, but yeah, it's fine. Oh no, it's not sketchy at all. As long as you have a good vice, as I have, it's fine. It's just fine. As long as you machine it on a same machine, so you know pretty much the tolerances will be the same. It's fine. I do it all the time with some other of my stuff. I never had any problems. So yeah, should be fine. So let's go to the manufacturer. So let's machine this side for, oh, I forgot these thingies. Okay, let's open them all again. So Z. Okay, missing the X. X. Okay, so as I was saying, since I bought the shims, so we can adjust the preload. So the initial idea, and since I have the Belleville washers in here already, so these are supposed to be 1.6, so 3.2 if we put two together, but I found out it's a little bit less. It's actually, instead of 3.2, we actually only have 3.1 ish. So we were aiming, if I remember correctly, for 0.5, right? Preload, or 0.4. Yes, 0.4. So supposedly they are 3.2 minus 0.4. It's 2.8. And as you see here, I have 2.78 already. But actually, we're gonna go deeper. We're gonna go like 3 millimeters. So like a 0.1 preload. No, it's 0.5 because we have the nut. It's gonna be 0.1 millimeters. So we're gonna aim something like a 0.3. And then we can add shims to compensate and do the preload that we actually want. If I'm explaining myself. So let's do all the math. So supposedly full, if we go full, the nuts full down, it's minus 3.2. But we want the nut to be 0.1 away from the... we know the nut is 0.1 away from the nut holder. So let's put 0.1 back. And we want... initially we want a 0.5 preload. But let's go like 0.2 or 0.3 instead, and then we add the shims. So to adjust what we want. I ordered two types of shims. I ordered a 0.2 and 0.1 millimeters. So we can get with one shim, we can get 1 or 2 tenths of a millimeter. And if we do two shims, we can do 3 tenths of a millimeter. So I will say we just add like 0.3 of preload, or even 0.4, or I mean 0.2. Yes, 0.2 is less, and from then we can adjust whatever we want. So like that. So it's a 2.9, so it's a 3 millimeters. So we only have 0.1 millimeters of, yeah, 0.1 it's too little. Let's do 0.3. Yeah, that should be fine. And we go from there. So 2.8, it's the final value. So let me do the math again. So we have 3.2, which actually it's 3.1. So with 2.8 we actually have 2.9, 0.3 millimeters of preload. Yeah, let's do a little more. Let's do a little more. Oh yes, you can. You didn't know you could do. You can do math in here. You can multiply. You can do whatever. You don't need to. You don't need to put just a number in here. Yeah, let's do a 0.2. Because I'm kind of scared. I prefer, but I can do, it's just a little bit of aluminum anyway. So even if we have to repeat the parts for the prototype, it happens all the time. So I can adjust, even if mine takes like 3 shims, I can adjust then the kits to have less. Doesn't matter, I don't mind. It's always a good idea to actually put a shim there, so so the spring actually will sit on steel instead of sitting on aluminum, which can create kind of a bed. And the steel, it will create a bigger surface, and actually it's better to use at least one shim. So yeah, we're gonna work with that. So 2.9 is gonna be our final value. So let's do that on all of them. And we may end up finding that my math is all the way wrong. So okay, we are done. Well, they, like every spring, they suffer from fatigue, but it will take a damn long time. So we use these things, for you to have an idea. We use these things, smaller ones, which are more prone to fatigue. We use these things on high pressure regulators on our guns, on our air guns. So we use like 8 of these to create or more actually, like 8-10 of these to create springs, and they are under pressure all the time. I mean all the time, and they last for, well, actually I never had to replace these things on a regulator, and I have guns with more than 10 years of regulation. So yeah, and these things are all the time cycling. Every time we do a shot, these things cycle, and when we don't do a shot, these things are under tension actually. So they just relieve when we make a shot. It's when they actually open, and yeah, it's gonna take a long time for them to settle, especially under such a low preload as we are using. Yep, they are very strong. We need strong springs, and which occupy a very small space. So very compact. You can't get a coil spring as strong as these and as small as these. There's just no way. For you to get a coil spring as strong as these, you're gonna need like 5mm wire spring or something like that, or even more. So we need the springs to be very strong and very compact. They are not the most precise thing in the world, but they are good enough. Pretty much every brand of air guns that make regulator air guns use these springs for their regulators. Okay, anyway, let's go. Oh, okay, let's update the models. Update all. Close. Let's do this last batch of parts. So these things 133. Actually, I'm gonna split them a little more apart. So instead of 8mm, I'm just giving another one. It's a little more waste, but doesn't really matter. And I'm gonna need to adjust the size of my stock. Go away. So, same shit on a different day. Create new setup. The axis is going to be this one. X-axis is fine. Stock. So my stock should be about 37. Actually, it's 38 and a little bit more. So let's set 1.5 millimeter around the stock, 0 on top as usual, and it's 20 millimeters. So let's set 3 on bottom. No model select, okay. No. So now, since we have multiple models, we actually need to go to select, because we can choose to machine only one model. Okay, so here we're gonna have a few considerations to make. I should increase this even more now that I'm thinking about it. Yeah, I'm gonna increase even more, because I'm gonna machine these with 8mm mill instead, and I'm gonna understand why in a minute. So I'm gonna do 10. Move. Okay. Manufacture. Stock automatically updates. If we're gonna check here now, stock is bigger already. So we have 10 and we have 10. Okay, so instead of using a face mill to face these things all together, I'm not gonna do that, and why? So what I'm gonna do, since this is a critical dimension here, so this one I can use, but since this is a critical dimension, and when we have tool changes, we have some kind of variation on the height, especially on the pt2, which is my machine tool changer type. The Z, it's not absolutely spot on every time. It varies a few cents of a millimeter. It would be fine for this application. But in order to minimize that, what we're gonna do, we're gonna face it with the actual mill that we're gonna do this boring operation. So that way that we have no tool changes, and it's gonna be spot on, or at least as accurate as the machine can be, machining these pockets. So that way we're gonna start with well, we can start with, yeah, let's start with the adaptive. So new operation, adaptive clearing. Let's go and select all 3. I selected the top because this guy here has a step, and it's a little trickier to select the contour. So then we mess with the heights. So the bottom height, we're gonna do selection, and we're gonna select that guy there, which is the lowest point, and we can give it a little more offset, so -0.2. Of course, we can do that on a stock to leave as well. So axial stock to leave we put none, and radial stock to leave we leave the 0.2. We can lower this value a little bit, 0.8, 1.8 should be fine. And we can also do the inside pockets while we're dealing with it. So let's select the tool, rough, go. Oh, okay, we need to edit the cutting radius. Let's set it to 0.3, should be fine. Be enough to allow us to machine the pieces. So roughing is done. So doing the roughing first, and when you need some kind of accurate depth, it's a good idea to, well, on my machine I always do a warm-up cycle first, where I run the spindle at multiple RPMs, and it will increase the RPMs over time. So it takes like 10 minutes to do a full warm-up cycle on my machine. So why is this? So it's two things, to spread the grease on the bearings first, of the spindle bearings, and to actually warm up the spindle, especially now on winter, which is very cold. The machine is very cold, so the metals are retracted. So when we do a warm-up, the spindle, actually the parts grow, and if you have critical depth dimensions to hit, it's a good idea to have the spindle warm, so you make sure it doesn't warm up during those operations, and you're gonna have fluctuations on the Z depth. This actually happened to a friend of mine that also, actually built a machine a lot like mine. And the first time he flattened his table, so he used like an 8mm mill to do the flattening the table. So if you use a smaller mill, you're gonna have less trimming error because it's a smaller cut. So if you have any trimming error, it's going to be minimized because it's a small cut. If it's a big cut, the angle, it's going to create a bigger step. So he was having a problem that he started with the machine cold doing the facing, and it took a long time because it was like an 8mm, and he had to run like 30-35 centimeters of Y. So he was having a problem, and he came to me because he was having a step down on across the table, and in his mind he shouldn't have. And the first thing I asked him, it was exactly that: did you warm up the spindle? And he was like to me, nope. Why should I? And yeah, exactly because of that, the spindle starts cold and the tool starts higher, and as it goes warming up, it's gonna start growing and digging deeper. So after that, he warmed up the spindle for like 1 hour, and then he ran the table, and the table became perfectly flat. And he said to me, well, I could be here a long time before realizing it would be the spindle heating and growing and creating that problem. So if you do a few operations first, you're gonna create you're gonna do a warm-up on a spindle, and then you do the operations one right after the other, just to minimize the difference in temperature of the spindle. So okay, we machined the bigger part. Let's do the finishing. So let's create. Let's create a derivative operation. Should be fine. Create derivative operation 2D contour. And so the contours should be done already. I'm thinking, yeah, it's fine, I don't care. So the lower point, let's give it a little higher, just a nudge. Smoothing. Where is overlap, it's fine. So linking, in this case, I'm gonna put to start here. Inside doesn't really matter because it's a round. Why did that one didn't select it? And what I'm gonna do a repeat finish pass. So what this is gonna do, it's actually it's gonna do a spring pass. It's just gonna repeat the pass to make sure if there's any deflection of the tool, it will just do what we call a spring pass. Single depth should be fine. What? Drill positions. Okay, I probably fucked up. I selected drill position instead of... oh yes. So what I want is preferred lead in position, not drill position. Okay, so it will start there. And create everything. Let's do simulation preview. Everything fine. You see it repeated the pass fine. So now we did everything pretty much we could do with the tool. Now we're gonna face it with the same tool. Tool milling face. We could select just to face the parts, but it's gonna mess. It's gonna lift Z and whatsoever. There's no point. So I'm gonna do 6mm step over. Oops, 6mm pass extension and 6mm step over. 5.6 would be pretty much the same. So it will face with... Oh, I don't need a step over. Let's put like a 3mm step over. Yeah, 3mm step over, it's fine. So everything fine. Now let's do boring operation. Bore, and let's do the boring on the I'm not sure if we should do a boring or... Yeah, boring is fine. It's finished, yes, okay. So we do the facing and immediately after we do the boring to prevent, to do what I was talking about, to prevent. We want the operations as close as possible. And we are done with this mill. Now let's do chamfers and spot drills with the chamfer drill or the spot drill. You guys call it what you want. It's a spot that do also chamfer. Let's start with spotting. So let's select the same diameter. And so these are supposed to be M4 threads. So let's do chamfer diameter to 4.2, and I like to do the dwell to make sure it gets to the right depth. Now let's do some chamfers. These are just edge breakers. It's not really a big chamfer. It's just to break the edge, because usually we get some burrs, and this way it's just a cleanup. So let's do something like 0.3 millimeter edge breaker. Oops, yes. That was saying I forgot to select the chamfer speeds. So it does this edge breaking. Okay, let me do something. Let me put something like 2 millimeters here. Yeah, it's better. Oh, okay, I can't. What is this warning? Cutting feed rate. Oh, okay. So I did. Yeah, that's a bug. Everything is fine. It's just a bug. Okay, let's do simulation again. Phase. We do the boring. I need to check if the boring has a finishing pass to make sure. Otherwise, I'm gonna change the boring to edit finishing passes. Okay, we can do this. Yeah, we can do this. It's better. So what it's gonna do, it's gonna do a finishing on the a finishing pass around, which will act as a finishing pass on the floor, of course, as well. See, you just do a finishing pass. Okay, now let's do drill. So M4s take 3.7 millimeter drill. I don't think we did any M4s yet. So let's do a tool 91. If we have the 3.7, if we don't, we create it. Okay, let's duplicate the 3.7 mil or tool. So now we have two. Now we edit, and we're gonna put 91. So it's the tool 91, and now I have a 91 tool with 3.7. And geometry, we're gonna select all of them. Boom. We're gonna, on heights, we're gonna put to drill through. Let's drill through 1 millimeter to make sure that everything goes down. It's a quite thin hole, so we're gonna do deep drilling and something like 2.5 millimeters per pack. And now let me just make sure that we don't plunge the stock, because I don't like to eat my parallels. And we are good on this side. We have the edge. Oh no, we still need to, how far am I from the, we are quite far, so let's add a little more. 2 millimeters. Let's see if we can get through. Yeah, we can. Okay, so let's do the tapping. So I need to check this. I'm pretty sure my tap does 16 millimeters. Yeah, I'm pretty sure it does. I need to check it, but so again, drill. We can actually duplicate this tool. Hit it. So now we're gonna select an M4. It's gonna be tool 12. M4 tap. Yeah, my taps are not even close to well defined on Fusion. They should be, but they are not. So faces, those faces, heights, definitely not. Well, no. I'm gonna put just -1. If I need to finalize it and by end, I'll do it. That's fine. And here we need tapping 0.5, and we should be good to go. So let's simulate everything. So we do that, we do that, we do the facing, we do the boring, we do the spotting, we do the chamfering, we do the drilling, and we do the tapping. And we are done. Okay, so now what we can do, we can machine the tops, which is only 1, but it needs to be machined, so why not? I'm just do it a little of syncing. 30. How long is this? 4. This will create a burr, but that's nothing I can do. I need to then manually remove it. So, okay, let's create a new setup. models. We need to select all models. We need z-axis. Actually, it's like that. So that and fuck me. And that. I need to flip X. Now I need model origin or model box and that point. And we are there. And everything else is fine. So I'm gonna need to bore this thing. So new operation, drilling, bore. I'm gonna select both. So I think I'm gonna use my long 6mm. So let me search for 6mm. 6mm long. Finish, select, and bore we go. So I don't like to do this because so the tool is all 6mm, and in theory the actual flutes are a tiny little bit less than the chunk because of the sharpening. So if I do a boring, this is a 40mm long boring operation. It means it gets to a point that I'm actually rubbing the so won't that origin point have been machined? No, because I selected here I selected the model box. So one thing is the stock box, which is the yellow box, and the model box, it creates a virtual box around the model itself. So it's a box of the size of the model. So we can actually probe the model now. We can probe here for Y, we can probe here for X, and we can, if you see, the origin is inside the stock. So now we can probe the model itself. And if I select here stock box, you see the origin moves to the yellow box. Now this would be a problem because it's machined away, but the model box, it's actually not. We have this face machined, which is there, and we have this face here, which is aligned with there, and we have the Z face, which is aligned with that. Okay, so I was saying, here I'm gonna do a 40mm boring, and I have only 25mm of flutes. What I really like to do in here, in this case, is I'm gonna duplicate, and it's not, the dimension of the boring, it's not important here, so that's why I'm gonna do this. And what I do is the first boring operation, it's going to be from whole top to whole top minus 25, which is the length of the boring head, of the boring of the flutes of the end mill. Actually, I'm going to do 44. And what I'm going to do on the stock to leave, I'm going to actually enlarge it by something like 0.07. And the second one, I'm gonna do all top minus 24 and without anything. What this will make, it's gonna make a slightly bigger boring first with the 25 millimeters of the flute, or in this case 24, and then we're gonna finish the second one slightly smaller, so that way the chunk will not rub on the machining walls. So if we simulate this, let's finish everything. So here you see we are eating a little more than we should, and the yellow represents the size of the flute, so it's the cutting part of the mill. And then you see the mill will stay away from the wall on this part that doesn't cut. Okay, I'm not making the drilling. I can make the spotting though, because yeah, I'll make the spotting because I want to make a chamfer anyway. So let's create drilling. Let's select the chamfer. Okay, let's do spot, and let's select the holes. Same story. So these are supposed to be 4.2 millimeters, so let's do a chamfer diameter of 5. And we're not going to drill it because we need to drill anyway from the bottom, and the drills are all the same size. Well, actually they are not. Well, they can be. Yeah, there's no problem of making these instead of 4.2 millimeters, make them 4.6. So we make all the drills the same size. It's one tool change less, and I don't think my drill can actually go down there. So anyway, so let's create an again new setup. Same story. Z-axis, X-axis, flip. Now model box that corner, and that's about it. Oh, okay, we have to select the models. Fine. So spot drill, new operation, drilling, drill. So spot drill. We're gonna do all the same. Doesn't really matter. I could do the select same, but I didn't. Anyway, so they are supposed to be mostly M5 M5 threads. So let's go to chamfer diameter 5.8. Yes, we are getting this, but this is gone already, don't forget, from previous operations. Now we're gonna drill it. Drill 4.6, which is the tool 90. So here we gonna okay, here we're gonna do different operations because I need different depths. Okay, this one is good. This one is good as well. This one is good. This one it's not good. But it's not like I can select which ones I go further. So let's do this together. I'm not even bothering doing steps because it's such a small drill. So edit, let's clean this, and this guy here, it's going to be different because we want to push through the hole actually. And those guys, I can duplicate it again. Beware, because when you duplicate an operation, it's going to be right after the one that you duplicate. So here we're going to use the M5, which, if I remember correctly, it's the tool 11, right? Yes, the 12 it's M4. We haven't used anything else yet. So now we need to be careful. What I'm gonna do is I'm gonna offset 2 millimeters, and then I'm gonna finish the tapping by hand until I feel the tap hitting the bottom, just to be sure that I don't fuck up. So let's do a simulation. So drills. Yeah, I can't. Oh, I can, like this I can. What am I doing? Okay, it's doing the drilling. Yeah, it's going there. It's going there. This one, it's not gonna do anything. Yeah. This is fine. then I can just bottom it by hand. And now the final operation, or the final setup, I should say. So same story, z-axis and x. Model point. I'm gonna use that one. Model box, sorry. I'm gonna use that point. And this one, it's gonna be funny. Pretty much we are okay. I need to select. I always forget to select the models. The CAM system automatically select them all, but okay. So here now we have a slight problem, right? Because we don't have everything on the same height. So these guys are 16s. These guys 17. So how are we gonna do this? Well, it's kinda whatever you like. So one thing we can do is do, for instance, okay, maybe the 3D milling, adaptive clearing, it's the best. So what's the difference between 2D milling and 3D milling? So 2D milling, you're just, it's like you machine X and Y, whatever, at a specific Z, or at specific Z's, according to the selections or whatsoever. And 3D milling actually interpolates all the three axes. So 3D milling, it's more intelligent on the on fusion, and you can actually, so in this case actually probably it's the best idea. So we can do a 3D adaptive clearing. Let's use my favorite tool, the 8mm tool. And in geometry, you don't select a geometry. The fusion actually looks at the models and will program accordingly. And now you ask, why the fuck don't you use always 3D milling? Well, I like to do the stuff the hard way. I like to do steps to make sure everything is machined as I like. Here you can select the lowest. The low, we can select that guy because it's the lowest part that we need to machine. And we leave 0.2 millimeters as usual. The roughing step down, what's the roughing and the fine? So these will, let's say you have a ramp somewhere in here. So it will create steps according to this value. So the roughing, the maximum roughing step down, it's like the big step. So it machines 8 millimeters down, go all around, and then goes in these steps up. So first it starts with 18, and then it goes 1.8 millimeter up from the 18, and machines whatever it is to machine, and then another 1.8 and machines whatever, and go what so on. So I'm not sure. Let's leave it like that and see what it goes. Optimal load, let's do 2.5 like that, and let's see what it does. But it's kind of dumb That's why I don't use it too much. Let me see, why doesn't... So you can select surfaces to avoid on whatsoever. Now what I'm wondering is why somewhere they changed this thing from... Okay. Yeah, that sucks. Okay, so there's these options in here which you can... Basically it will look into previous operations, but it doesn't look to previous setups. So the only way it can know that the this is machined, let me see. Let me see something. I remember there's a way to save the stock. Okay, so I don't like this way. So what I'm gonna do, horizontal is an option. Yeah. Okay, I have another idea. I'm gonna do... an adaptive clearing, a 2D adaptive clearing of this guy at no, actually what I'm gonna do, it's different. I'm gonna do a facing operation first. Face operation. I'm gonna select my big mill, and it's gonna do a facing all the stock to the model top, which is that guy. So what So what this is gonna do is I want multiple depths, I want 1 millimeter, finish step down 0.2, and even step, okay, so what this is gonna do, it's gonna face everything to this height. So this height is done. Now I'm gonna do a facing operation again. But I'm gonna select this guy and this guy. And I'm gonna actually... I'm gonna put it to selecting 90 degrees. Let's see. Okay, that's what I want. So what this will do is it will face everything to that guy. Then it will face these two. Oops. Okay, I fucked up. Bottom height, I need to do selection, and I need to select that. So I'm selecting that point because it's the it's a point at the low height I want to face it, and there we go. That's what I want exactly. Let me do the same stuff. Multiple depths, fine, step down, 0.2. Okay, but we don't need to start at the top. So we can do here a selection, top height, and since we have everything machined to this point, so we can select that point as the height point we need to go from, and we go like that. And now we have those pieces flattened. So the only one missing is this bastard here. So now to face that, we need to actually go with a adaptive clearing, red beast, 8mm, rough, and we can do something like, yeah, like this. Yeah, that's it. That's what I want. I just don't want it to be so aggressive. Let's do 1.5. And this looks a little bad, but okay, let's do some other stuff. Instead of a 2D adaptive, let's do a 3D adaptive actually. Let's select the same tool. Rough, that's fine. Now here we can do some stuff like as can't I? Okay, doesn't matter. It shouldn't be a problem anyway. So what we're gonna do is boundary. So boundary, it's bounding box selection. So boundary, it's basically a limit where the tool doesn't come off. So what we're gonna do is to outside the boundary. We're gonna get it a little offset. Let's see if this works. I'm not sure. Sometimes I need to test a few operations until I get what I need. So on bottom height, I'm gonna select this height because we don't need to go further this. Everything is machined. And it should take into account that everything else is machined. I don't care too much about the settings now. I just care to see if I get the result I kinda want. And looks like I actually, this is getting too close to that guy. So let me decrease the offset here to 1. So we see, there we go. That should work. It's not the most beautiful toolpath or the most efficient, but it's definitely fine for what we need. Because if we, let me just, it should know, but Oops, sorry. Let me just edit the top. You know what? Fuck that. Let's do it the old-fashioned way. So let's go to design. Let's do a sketch. Capture position. Let's just do a rectangle here. Let's make this line coincident with that one for collinear. And that's fine. That's fine. That's fine. And we can use these as a pre-drill position. So new operation, 2D milling, 2D adaptive. Let's select that guy inside. Whoa. Well, we'll see. Doesn't help too much. Let's select smoothing. And let's select pre-drill position, this guy, because this thing is open already from the previous operations. Let's select the tool, rough. Okay. Whoop. Did it? What's happening? So we have the close chain disk. Hey, wait a minute. What am I doing? Hey, what happened here? Okay, so this is the first setup. This is the second setup. Didn't I created a new setup? I created a new setup. Where did my setup with the face mill went? Did I delete it by mistake? Probably. Okay, I deleted the... Okay, I see now. I deleted the setup instead of deleting the operation. Never mind, let's do the sketch again. So this guy, collinear with that one. This doesn't need to be super duper precision as long as that line is there. Okay, now we're talking. Adaptive clearing with our good friend 8mm rough. So now we select the square. Now we're talking. And we select 1.5. We don't need to be too aggressive. And smoothing. And we select a pre-drill position, that guy, because that thing is there. So it's just gonna take there. That's fine. That's what we want. And now we create a new operation to the milling pocket, and we rectify this guy. Step over 5, that's fine. Stock to leave. We can do nothing. That's pretty much fine. Actually, we're not gonna select. We're gonna select our square. Gonna be better. Yeah, that's fine. So the only thing we need to do is to do a pre-drill position. So it starts in the middle, like that. Beautiful. And we should be fine. Let's see. Let's simulate everything. Should be fine. Okay, so this thing is do chamfers, drill, stops, top. Oh, I forgot those chamfers. I need to put some chamfers there. I'm gonna do it next. There. Spots, drills, tabs, faces. This face. That. Pocket. Beautiful. Done. Okay, so now we just need to do some chamfers. And we are done. Okay, on the bottom, on the top, I forgot to add some chamfers on those holes. Let's do that now. New operation to the milling to the chamfer. Let's do it like that. On heights, I'm going to select model top on both. Highest of model top. And let's do like, I really want to catch that guy, so let's do a big one. Let's do like a 1mm chamfer there. Fuck you. No. Chamfer. Fine. Okay, Fusion is starting to acting on me. Let's see if it does what we want. I'm not sure. Go. Go. Come on. What happened there? Something happened. Okay. So this is the first boring. Come on, process it. Second boring. Process it. Spotting. Yeah, okay, so the point is just to get a little bit on that guy there, just to make sure we chamfer it a little bit. So we are good. So let's go here. So here we gonna learn a new thing. Let me disable that sketch because it's driving me crazy. Okay, so let's do some spots first. Drilling, drill. Red beast. Spot. These guys, all of them. So they are M4, so let's go to chamfer diameter 5. Should be fine. Dwell, fine. Is it me or maybe it's a little too much? Let's do 4.6. Yeah, looks decent. Okay, so now let's do the rest. So 2D chamfer. So let's do this guy. Let's do these guys. Just breaking the edge, and let's do these guys. Let's leave that for last. Okay, so let's do like a 0.3 millimeter chamfer. No, no. Chamfer, fine. Okay, so it does the breaking, and now this is where the duplicate. This is where that expression that I use. So you guys remember when I talked here about this expression that I use. So we use the so this thing it's to use the most. So we can cut the chamfers the closest to the edge of the tool we can, and this is why we want to do it, because when we need to do this kind of chamfer that we need to stay away from a wall. Usually it does. You see the arrows. Usually I don't even check, and when I do the simulation I see if there's a wrong chamfer, but 90% of the times it chooses the right way. Okay, so I'm gonna remove all the others and I'm gonna select that one. So in order to get the most until the closest here of the yep. So, and you know, if you have the red arrow shoot outside, you know you want the tool to pass on this side, right? If you have the arrow from on the inside, you know you're wrong, because it means the tool will come on this side of the line and like that. So, but yeah, usually it selects it well. Okay, so I was saying, in order to get the closest to that point there, you need to move the tool the lower as you can and the closest as you can from the this wall. And this is where this value here, the chamfer clearance, is exactly the how far is Fusion allowed to get close to the wall. I usually go to 0.1, and of course we can simulate that. So now I'm going as close as low as I can, and this is the result we get. See, it's very close to, so it's just that little bit that isn't chamfered. And if I go there and I edit, and if you go like 0.5 millimeters, you see the chamfer starts much farther away, and you have a lot more without a chamfer. So that's why it's a good idea to have this expression here. in order to make the close as you can. In theory, you can go even closer, but either my tools are not good, which they are not the most expensive. Because I can't go, if I go lower, I get a burr on the chamfer, and I don't like that. So I prefer to have like a millimeter there without chamfering, than have raising a burr. So now if we simulate everything, we should be good to go. So I'm gonna jump through everything. That boring operation takes some processing. Okay, so see, it's very close to, so this is a very small part. As you see, it's very close to the edge there. So yeah, we should be good to go. So the purple is the tapping, so it means the tapping doesn't get to the bottom. I'll bottom these things manually after. And yeah, this way we finish all the 3 nuts in roughly 20 minutes. We do all the three nut holders. We could make some engraving saying which one is what, which one is which, like on the top maybe. Would be fun to put like X, so this one is the X, this one is supposed to be the Z sync, and this one the Y, right? I think so, something like that. But I can also do it with the laser after, but it's just more work. Yeah, we could do that on top. So yeah, Y, X, Z. Yeah, maybe. Yeah, we can do that. So let's go here. Let's create a drawing. Fuck. Let's create a sketch in here. Yes. So let's create some text. So this one is Y. Well, actually, it's a cool size, but let's do it a little smaller, like 8 millimeters maybe. Yeah, 8 millimeters look good. Roughly centered. There's no way for me to actually accurately center these. So let's just eyeball it. Looks good to me. So fuck. Control C, Control V. It's gonna be X. Come on. It's only one still. Yeah, it's fine. What the fuck? Why can't I? Okay. X. Yeah, that's fine. Kinda. Oh, we can't count squares, so we have 1, 2, 3, 4. 1, 2, 3, 4, and a little bit, so that means this guy is a little high. 2, 3, 4. 1, 2, 3, 4. Yeah, that's fine. Okay, it's fine. And this guy is the Z, right? Control C, Control V. Oops. Fuck. So this guy needs to come a little bit more. I think this is the midpoint, right? And create a midpoint. Ah, okay. Let's do a project. Let's construct point there. So this guy is Z. Let's make this one a little smaller. An engraving bit, just a regular D shape, what they call a D shape. A D shape bit, that's fine, okay. So now E for extruder, or extruding. Let's go 0.2 millimeters, that's fine. Okay, I see it created the lines. Edit feature. Not new body, cut. I can't. Okay, it doesn't matter. Okay, let's create new bodies then. That's fine. So manufacturer. So on top should be this one. Let's call it, let's give it names. So this thing is front. The last one is back. This thing is top. And this one is bottom. Fine, so let's go to the top. Let's create new operation, 2D milling, engrave. Now, so it's one of these thingies. Let's go 0.3. So it's one of these thingies basically. So, but it's cut in half. It's like, it's this, it's like this. It's a D, okay, it doesn't really matter. I don't have any in here to show. So we can go and do, fuck me. Can do and do that. That. And that. So what we do is top height, let's make model bottom, model top, and bottom height, let's make the same thing, model top minus 0.2. The fuck? Yeah, okay. I usually don't do the engrave. This engrave toolpath is it's not new, but it's recent. And usually I just do a pocket. 2D pocket. Select the same tool. Yeah, it's here already, so let's select it. And let's go. I could do it with if I just did like traces, like a single, but I don't like to do it with the chamfering tool, because if I break the point, it's a mess. So I'll just use the a specific engraver tool, and we need speed for these thingies. So yeah, that should be fine. That should be fine. Smoothing deviation, we need something a little more accurate. Let's do 2 depths, like 0.15. Yeah, that should be fine. 0.5. Stock to leave, none. Let's see. Okay, we're almost there. I need to select the heights, so model top. Same story, model top minus 0.2. There we go. Oh, it's not good. Model top minus 0.2, that's fine. We don't want ramps, we just want plunge. Oh, okay, because this is showing the stock. Okay, that's fine. Okay, so let's see. Let's finish everything. Yeah, looks decent. Yeah, fine. Okay, let me just make sure. Okay, epsilon, y, z, and x. Okay, so we are done with the nuts, the nut holders. Let's create the setup sheets, and we are done for today. Setup sheet. Yeah, that folder. So let me just. I can't. So machining nuts. One front. Oh fuck! I forgot to pose for the picture. Setup sheet. Let's go again. So let me delete this one and one. front, top, yeah, like that should be fine. Yeah, like that. Setup sheet, select, and here, to top. Top sheet, select, three, bottom, oops, I shouldn't have closed it, and finally the back, which is something like that. Or the back. And that's it for today. So yeah, tomorrow maybe, I'm not sure if I'm gonna be able to stream tomorrow. Maybe yes, maybe not, I don't know, but probably yes. So we're gonna continue to what? So what have we done already? So we done the nuts, we done the skirts, we done the spindle mounts. So next we're gonna go for the fun part. So we're gonna go for the X blocks. So these are 4 pieces. Yeah, tomorrow we'll see. We should be able to finish these in a few days. So let me save this. And go away. The hell, go away. Saved, and that's it. So we had some hiccups, but that's part of this job. So we finished a few more parts. Tomorrow or the next day we're gonna continue. And yeah, it's already 1 a.m. already. I wasn't expecting to be that late or to be streaming until that late. My brain suddenly woke up. Yeah, so we are done for today. See you guys tomorrow. I hope you guys learned anything new. And yeah, that's it. So see you guys tomorrow. Have a great evening. Good night, everyone. Thank you for the company, as usual. And I see you guys tomorrow. Bye-bye.